Hello students, welcome back to my channel. Today we'll study the topics of JAM group theory. That is, we will discuss some questions related to isomorphism and cyclic groups. Now let's get started. Now let's discuss some questions. Let's see if reals under addition is isomorphic to reals with non-zero reals under multiplication. This is not isomorphic. Why it is so? Because in reals under addition, only 0 has order finite, that is 1, and rest are of infinite order. While in reals under multiplication, -1 has order 2, 1 has order 1. Therefore, there are two elements with finite orders. Hence, they are not isomorphic. Second example, rationals under addition is not isomorphic to rationals, non-zero rationals under multiplication. Same argument would be given in both the cases, that in this case 0 has finite order while rest are of infinite order. In this case only two elements are of finite order, rest are of infinite order. Hence number of elements of finite order are not same and hence they are not isomorphic. Next example which we will do is rationals under addition and reals under addition. Rationals जो होते हैं हमारे पास वो countable होते हैं, while reals is an uncountable set. Therefore, it is not isomorphic. Another example, reals under multiplication and complex under multiplication. In reals under multiplication, we have seen that only two elements have finite order, while in complex, infinite number of elements are of finite order. क्यों? Because we have nth roots of unity. का जो concept होता है, that is x raised to power n is equal to 1. It has n solutions in complex for all n belonging to natural numbers. Therefore, we have infinite number of elements of finite order in complex under multiplication. And hence, they are not isomorphic. Another example which we will consider is matrices of order n cross n under reals with plus operation and general linear group under reals with multiplication operation. General linear group are matrices whose determinant is non-zero. So, in this case, this under addition is abelian, while as we all know that matrices की जो multiplication होती है, it's not commutative, therefore it is non-abelian, this group, and hence they are not isomorphic. Another example which we have is U8 and Z4. U8 we know is not cyclic, while Z4 is cyclic. Therefore, they are not isomorphic. Also, U8 is isomorphic to Z2 cross Z2. Now, another problem which we will discuss is which is cyclic group from the following, that is reals, non-zero reals under multiplication, complex non-zero under multiplication, rationals non-zero under multiplication. Then we will talk about Q modulo z under addition, 2z under addition, mz under addition. In first case, we have only two elements of finite order, therefore it is not cyclic group. Basically, whole of the group is not generated by an element, and complex finite order elements are infinite. In rationals, minus 1 has order 2 and 1 has order 1. It is also not cyclic. No. And for this, in this case, we have many elements of finite order because इसके elements किस type के होंगे basically p by q plus z if p and q are relatively prime. So इस element का order हमारे पास क्या आएगा q. But it is not a cyclic group because it does not have any generator. While 2z is a cyclic group because 2 is its generator. Similarly, m is generator. Therefore, m is its cyclic group. Have a property that is any finite, infinite cyclic group is isomorphic to integers under addition proof. इसका basically meaning क्या है? G generated by A is equal to e raised to power n such that n belonging to integers. Now f from G under group star to Z under positive is defined such that f of a raised to power n is equal to n for all a raised to power n belonging to capital G. F is a homomorphism. It is onto and kernel of f is identity. Therefore, it is an isomorphism, which in turn implies G is isomorphic to Z under addition. We also have another property that is any finite cyclic group of order n is isomorphic to Zn under addition modulo n. Another property which we have is any two cyclic groups of same order are isomorphic to each other. State whether it is true or false. G be infinite cyclic group, then first part G has at least two elements of finite order. Second is G has a non-identity element of finite order. In the above case, which we have done the examples of cyclic group, from there if we take mz under addition, here it is that it has only one element of finite order, that is the zero element of order 1. Rest of the other elements are of infinite order, therefore first statement is false, and similarly second statement is also false because it does not have any non-identity element of finite order.